So, R in the humanities, text analysis. Let's get started. I'll tell you a little bit about myself first. So my name is Dr. Leah Henriksen. I say doctor because the novelty never wears off. But I'm a lecturer in digital media in the School of Communication at the University of Leeds. That encompasses a whole lot of things, including teaching students how to use R. But my research lately has focused on social perceptions of artificial intelligence and digital storytelling. And I use R a lot to complement the qualitative work that I do. So I use it as a kind of quantitative tool to support my findings, to point me in new directions. And that's what I'm hoping that you'll get out of this session as well, that you'll learn how to use R in a similar way. But my background is in the history of books. I have 2 degrees in book history. So if you ever want to talk about medieval manuscripts, I'm your gal. But as a result, I kind of fell in love with text analysis and the ways that we represent ourselves and the world around us through language. That's where I'm coming from. And then I discovered digital humanities, which this falls under. Digital humanities is a huge field, and I can't get into it, although I would love to. That's a whole other session. But if you ever find yourself wondering where to go for digital humanities resources and training, by all means, feel free to get in touch. I'm happy to point you in the right direction. And as you may notice by the massive flag I've strategically put in my background so people stop asking me what part of America I'm from. My accent is Canadian. If you ever want to get in touch, here are my contact details. They should also be in the kind of general course materials, but feel free to send me an email, and I'm quite active on Twitter. All right. So this is some recent work. I just wanted to give you a feel for the kinds of things you can do with R. We're not going to be doing this stuff exactly with R, but I've decided to put it up here just to give you a feel for where I'm coming from. I've spent quite a few months. This is the result of about a year with a Victorianist. We're currently waiting for this peer review to go through, but we're pretty hopeful that this paper will get published eventually. But what you're seeing here are 2 stylometric analyses of not all of the works, but a huge chunk of the works written by the Trollope family. So Anthony Trollope and his surrounding people. And stylometry is the comparison of different kinds of texts. And essentially it's for authorship attribution. So it groups like texts so that you can attribute authorship to unknown texts. This is all done in R. This figure on the left is very crunched, and it's a smaller version of a much larger interactive figure. But this is the kind of stuff that I've been working on. So if you ever find yourself looking to learn more about stylometry after this session, the reason I've not done a stylometric analysis for this module is I just think it doesn't make sense to throw you into that right away. I think what I'm going to show you is a lot more useful in everyday practice, and it's also a much better kind of way to learn R. But just so you know what I've been up to. So session 1, getting to grips with R. I've put some fun illustrations here because this is a really boring template. So you'll see my efforts to spice it up a little bit. But getting to grips with R, let's get started. Before we do that, I just want to quickly review what the overview of the course is so that we're all on the same page. We all know what to expect. So this is a gentle introduction to R. I am assuming that none of you have ever used R before. And I'm assuming that you have no knowledge of programming whatsoever. That might not be the case. If it isn't the case, awesome, great for you. But we're going to start from the beginning, really give you some time to play around with RStudio, get to grips with it before you go into more advanced activities. I think we sometimes, especially as adult learners, we jump into things and we want to be good at things right away, but we need those kinds of safe spaces to experiment and to fail. And I'm going to give you enough time to experiment and fail. I've scheduled that in. So we're going to talk about R. We're going to talk about RStudio as well, which is what we'll be using. And by the end of the course, you'll be able to navigate RStudio pretty comfortably. You'll be able to clean up those long-term prose texts for computational analysis. You'll be able to conduct those basic analyses. You'll be able to make some pretty pictures and actually explain what they're showing. And you'll be able to critically apply computational text analysis with other textual methods, things like close reading, those more traditional, for example, literary studies or content analysis. So hopefully you will have installed R version 3.6 or higher. That's if you just go to the R website, this link here, that's the latest one. And then RStudio, or no, it's not the latest one, it's whatever. And then RStudio Desktop, which is free. They have a quite expensive paid version, but you just need the paid, the free desktop version. There is an online version of RStudio, and the reason I've not asked you to use that is because I have not used it. So if you choose to use it today, I think it works, but I won't be able to help you if something goes wrong. Fair warning. So you use at your own discretion, but there is an online version that you can use. So today, what are R and RStudio? What can R help you do? A quick note about computational literary analysis, which I think this kind of stuff often goes overlooked in these sessions. I think it's important to just review. Then we're going to get started with R. You're going to have some time to play around in RStudio, and then we're going to get to cleaning the text. And then in next week's session, we're going to start generating those visualizations. We're going to start considering the ways in which we can use R to visualize our data. If you're not already familiar with what R is, it is the least Googleable term ever. Try to Google R and it's completely useless. It's a programming language. So you are literally, those of you who are doing second language teaching, you're literally learning a new language here. I also want to use this time to remind you that because you're literally learning a new language, go easy on yourself. You're not going to know the syntax off the top of your head. You're going to have to consult the internet. You're going to have to make mistakes, just like if you were learning French or Polish or whatever. So really keep in mind, like you are literally learning a new language right now. But R is also a software environment. So there are different functions and different packages that you can use and call upon to do what you want to do. At the end of the day, though, R is a statistical program. It is just a really fancy calculator. It's a little bit different from things like Python and JavaScript, which allow you to make things. You're just counting things in a really fancy way. So remember that that's what R is. When you get frustrated, you're just like, it's just a calculator. And I think one of the best things about R is that it's free, it's open source, it's community built. So if you go to the CRAN R project here, this is the download link for R, but on this same website, you'll also get a feel for the different packages that people have made and the different ways that people are starting to build on the kind of existing foundation. And then RStudio is what you actually use to engage with R. So you don't need to use RStudio, but it makes your coding experiences so much easier, so much more colorful, and so much more fun. I like to think of RStudio as that really helpful friend who gives you constructive criticism, but like in a nice way. And it does that because it's an integrated development environment. So you're developing and you're seeing your code manifest in front of you. You're seeing the results right away. Whereas if you were to just use R in some sort of text program, you wouldn't see it. You'd just see the code and then you'd have to implement it and see it elsewhere. RStudio allows you to make code and see it in the same space. So what can R help you do? Like I said before, R is just a big fancy calculator. So essentially at the end of the day, you're just counting words. This is what a lot of computational literary analysis does. It's just counting words. But counting words allows you to do some really cool stuff. It allows you to find linguistic patterns within and across texts. There are so many ways to do this. I'm only going to show you a few in these few classes. You can also compare texts. We're not going to do tons of text comparison in this, but that's kind of what the stylometric analysis I showed you at the beginning was doing. And you can make some pretty pictures. One of the reasons designers and data analysts like R is because the visualization tools are so customizable. You can make your graphs, your word clouds, whatever you're making, look exactly the way that you want them to. But it's still up to you to explain the results. And when you're using R or any other kind of computational tool for more traditional forms of analysis like text analysis, ask yourself whether this is actually the most appropriate tool. And as much as I love R, this is when I'm just going to talk to you a little bit very quickly, about 2 minutes, about computational literary analysis and the problems people have with it. And I want you to be aware of these problems so that you can anticipate potential criticism to your work. I've given you only 3 articles here. The Nanzi Da article here, this 2019 piece, put the computational literary analysis community just on its knees for a brief time. And people were really seriously worried about the state of computational literary analysis. So even though CLS has a really long history, for those of you who are doing linguistics, you might be familiar with Father Busa's work in the 1940s, making a concordance with of St. Thomas Aquinas's work. This image here is from a blog post by Melissa Terrace about the women computers who actually made that work happen. Very cool stuff. So there's a long history of this kind of computational literary analysis, this word counting, and this kind of, automated text analysis. But CLS has been criticized for example, misinterpreting statistical data, partially because a lot of times people doing this analysis aren't trained in the kind of intense mathematical methods that they're using. Unchecked enthusiasm for technological hype. So just because it's digital, people are excited about it. Again, check yourself. Is this the right tool to be using? Why are you using it? Make sure that you can answer those questions. It's also been criticized for turning literature into data and neglecting the reception of work. And while I think that argument's kind of not great, there is a real concern in privileging too much the content of the work and ignoring the people behind it. So just as you use this method, as you use R or any other computational tool for literary analysis, just make sure that you're staying aware of the social kind of situations of those works and the social context. It's important not to forget that people are the root of that text and they're receiving that text. They're always there. So that's just my kind of warning about some potential criticisms you might face by using these methods. Nothing that you can't overcome. So let's get started. I am going to turn off my PowerPoint now, although I've made these PowerPoint slides so that if you want to review what we've done, everything's available in the slides, but I'm just going to move them to the side for now so I can still see them. And now we're going to open RStudio. So double click RStudio. That's my brain. I'll give you a few seconds to just get the program up. So when you start your RStudio program, it probably looks like this. To get what I just closed, just double click this gray bar, anywhere on the gray bar, doesn't matter, and you'll open this little window here. So there should be 4 sections to the window. This is your terminal. All right, so there are 4 sections to this, this window here. I'm just going to go through them in a little bit of detail here. So this is your terminal. This is where you write your script. You can just type anything randomly in here, it doesn't matter. The great thing about this terminal is that it numbers your lines. So if I share my script with you, I can tell you to go to line 6 and you'll know exactly what I'm referring to. But if I put an actual code in there, for example, so if I ask it to do 1 + 1 and I run that code, you'll see it appears here in this section below. This is your console where your code is actually run. If you wanted to, you could type all your code into this console and it works just fine. The problem with this is it's impossible to edit. You also, every time you kind of run something, so if you click enter, it just automatically runs. You're going to get quite a few errors. It's really frustrating. If you press enter, and you can go along with me, just keep typing things as I'm talking, you know, do whatever you want. It's not going to break, I promise. If you press enter here, it doesn't run right away. You have to consciously run it. So this is a really good place, your terminal, the top left corner, to practice your code, to make it exactly what you want, and then you can run it and make sure it runs correctly. You have a lot less flexibility in the console. So I would discourage you from typing directly in there. So say that you want to delete your code here. You delete your code, you run some new, you have some new stuff, and you're like, oh no, I did this thing a few times ago. What was it? What was this code that I ran? In your top right corner, you have what we call the environment, the history, connections, tutorial, all this stuff. You can see all of the past codes that you've run in your history. So if you ever delete something and you're like, you can't remember what you did, but you want it back, go to your history. You can also clear it with this little sweeping brush here. So I'm going to clear mine because I don't want that in there. The environment here, you will see things as we go through our cleaning process. You will see different things pop up in the environment. These are all of the variables that you store. And a variable is just something that you've given a name. So for example, if I do my 1+1 function, but I want to name it, I can name it, and I'll show you how to name things in R in a second. There you go. I've created a variable here and it's shown up in my environment. Again, if you ever want to delete things, just use this little sweeping brush and you can start fresh. The final quadrant, I guess it's a quadrant. The final thing here is the bottom right. This is where everything else goes. This is like the miscellaneous pile. So right now you can see the files that are in my working directory. Your working directory where all of your data will go. So if you save anything from R or if you're grabbing anything for R, that's to and from your working directory. It usually is your documents. I'm going to change that. I'll show you how to change that because I don't want things floating around my documents, but now you can see all of my personal files. I had to clean this up for you, so you're welcome. When we start generating visuals, you'll also see them under the plots. The packages are really helpful. I tend to type in everything to do with packages, but if you're like, I don't know what packages I have installed, this will tell you exactly what packages you have installed. And I'll tell you more about packages as we go. And then you can turn packages on and off by just clicking this button here. It's a little check mark. And if it's not checked, it's not working. The help function is something that is probably the most useful part of RStudio. We will be using this a lot as we go through. We're just going to be asking for help. So you'll get that training that kind of, you'll automatically think, okay, I should ask for help just to double check that you're on the right track. So I'd encourage you to use the help, use it liberally, use it all the time, just double check. And then, the viewer. Okay, so awesome. So that is the basic space that you're working in. I'm going to just delete this. Now, I did say just very quickly before we go into the basic typing into R, and I'll give you some time to play around. There are two ways that you can run your code in your terminal. So if you click, just type in 1+1, and if you click enter, nothing happens. You haven't run it. If you want to run your code, put your cursor to the end of that line after the second one. You have two ways of doing this. You can go the long way, which is clicking this run button in the top right corner, and you'll see it will appear in the console. Or if you want to be very hackery and go the quick way, on your keyboard, just click Control Enter, and it will do the same thing. Generally a good habit to get into that so you can type things quickly. So now that we know how to run codes, you get a feel for the environment itself. Let's go through some of the basic stuff that you can do in R. And we're going to start with calculations because calculations for a calculator makes sense. So what calculations can we do? Well, let's go to our grade school mathematics. We have, I don't know, 10 plus 2. We have 10 minus 2. We have 10 times 2, and it's the asterisk that you use for the times. And then 10 divided by 2. The division is just a slash. If it's more readable for you, R is case sensitive. So any letters that you put in, if you put a capital, you need to be consistent with the capital. You put a lowercase, you got to be consistent with the lowercase. What it's not consistent with is spacing. So if you think, actually, I need a little bit more space to read, 10 plus 2, give yourself the extra space, works the same. It doesn't matter. So there you go. You have your basic calculations. I'll keep these up. I'll just run through the things that I want you to play with, and then I'll give you some time to play with them. And something that's also really interesting. So you'll notice here at the bottom in the console, this little 1 here. What is this 1 doing in the square brackets? It's indexing your answer. So we have a numeric value here, but we only have 1 answer. And it's saying, here's your first answer. It's not going to say, here's your second answer, because there's only 1 answer, unless somebody comes up with a new answer for 10 plus 2. That's not the case in all things. So if we go with the colon sign, 1 to 50, for example, surprise, it's going to give you all the numbers between 1 and 50. So the colon is up until. It's like a hyphen, kind of. And this will be really important when we start looking at our data. We're going to use this function a bit later when we have tons of data from our corpus, from our textual corpus, and we're going to want to just look at a little part of it. This will help us do that. But you'll see that the indexing here is saying, okay, here's the first answer, and then a new line, 46, 47, your 46th answer. This depends on your window size. So if my window were smaller, it would index slightly differently. But so there's that. Play around with the different numbers. One of the kind of key things that all programmers begin with, and I've not begun with it here, but I'm going to give it to you anyway. You can use the print function. I never use the print function in R, but it's fun anyway. Hello world. So what happens when we use that? Hello world. Oh, hi Leah. Now say I just want to, every time I type the word hi, I want hello world to come in. Let's do that. Let's make a variable. So I've named this function. Print is a function. It's an instruction that R knows how to execute. So every time I type hi, hello world, hi Leah, hi. And it's just unlimited amounts of fun. I'm a child. So great. So I've taught you how to name variables, have fun printing all the things that you want to print. To be honest, you don't even need the print, I think. I've not done it this way, but I'm sure you could do it like, or hi to. Hi Leah. Let's see if that works. Hi to. Yeah, that works too. So the print function's redundant. You can see how much I use that, but just a good time. Keeps the kids busy. So we have that's our variable names. And you'll notice that our variables come up in the environment, like we said they would. Now, the weird thing here, I'm just going to show you one function that's unusual for R because it's one letter. Most R functions are really clear. They tell you exactly what they're going to be doing, right? So things like print this out for me. It's obvious what it's going to be doing. This is not an obvious one. So let's just have a variable called test. And you'll notice that in order to name a variable, I'm using this arrow here. I'm making a little arrow. So little less than arrow and an end dash. And I'm going to use the C function. And C just means combine. It means put this into a single unit. And then in brackets is you have the instruction, and then what you want that instruction to actually do goes in the brackets. And let's just do 1, 2, 3. So you'll notice in the environment that we have a numerical combination of numbers here. So if we type test, we get what we made here at the bottom, 1, 2, 3. Now say I only want to refer to this second one, right? I only want to know what the second number in my sequence is. Test, and then in square brackets, 2. There you go. You can also do this, test, square brackets, 2 colon 3, because remember here that 1 to 50, that gave us 1 to 50. So 2 colon 3 will give us the second and third numbers, 2 and 3. So this is just the way that we reference data, the way that we look at data in R. It is not obvious. It is not clear. And sometimes it isn't even this way, depending on the function that you're using it. But for the most part, it's this way. So just get used to this kind of stuff. I'm just going to see what else I have here. So I think at this point, just looking at everything else that I gave to you, I think the only other things that I want to remind you of here So we have our basic mathematical functions. You can get really creative with this. So write out those really intense mathematical functions that you dreaded when you were in, 5th grade. Try to solve the math if you can, and test your R knowledge that way. It's a really good way of doing this. But two things that I want to remind you of. If you ever want to keep notes on your code, if you're like, I'm never going to remember this. So let's say I want to remember this 1:50 because I'm like, I'm not going to remember colon. Put a hashtag, an octothorpe, and your text will turn green. And that means that it won't run as a code. It will just be there as a note for you and anyone else reading the code. Start a new line and you have to give another hashtag or else it will run. So just one hashtag at the beginning of the line. If you really want to draw your eye to the notes, put a bunch of hashtags. That's not uncommon. Quite a few people will do that to just make a separate line between sections. But if I want to just say use colon to reference specific numbers or something like that, something that you're going to remember. So as you play around, try to give some notes as well. It's really good practice to put notes in your code so that if you're sharing it with someone else or just your future self, you can easily work out what you did. The only other thing that I want to mention to you here is the help function. I said that I'm going to force you to use the help function. I use the help function all the time. And I think we go into this kind of stuff being like, I don't need help. I'm just going to do this myself. I'm going to remember everything. No, don't do that. This is way too complicated and there's just so much going on. There's no way you could possibly remember all of this. So if you ever need help, put your question mark, just a question mark, and then what you want help with. So say I see this C function here, and I'm like, what the heck is a C function? Is that even a function? What is the meaning of life? Put C, run that code, and in the help, it will tell you, C, this base thing means that it's part of the base R program. It's a core R functionality. But it will give you exact instructions, not just on like how to use this thing. It'll give you recommended uses. It'll give you tons of information about the function itself. This help is fantastic if you're writing a paper and you're writing a paper for people who don't know anything about R, who don't know anything about computational literary analysis. And they ask you, and they will ask you, how does it work? And you're going to be expected to give some sort of crazy mathematical explanation. Come to this help and see what help they've offered and see if you can maybe cite this or work from this to work towards your own definitions of how things work and your own explanations of how things work. Tells you, I mean, this gets quite complicated, but it tells you exactly, some examples, some functions that you might want to be using as well, or instead of. So this help function is fantastic. If it's easier for you, if you're not going to remember the question mark thing, I think that's a much easier and kind of sexier way of going about this. But if you're like, no, thank you, Leah, I'd rather use words, type help. That's a function. And then give that function specific instructions. Here's what I want to know about. It will bring you to the same place. So there are two ways to get there. Pick which one you think best suits your style. So at this point, I want to give you about 5 minutes to just play around with RStudio. Take some time to go through the different tabs at the top. The ones that you might want to check out are under File, and then under Tools and Global Options. That might be fun to check out. I'll show you a global option that we're gonna look at in a sec. Try doing some mathematical formulae. Try naming some variables. Just fail. Go forth and fail and flail and have a good time. Just so you're aware, there are different data types in R. So what you're seeing here, for example, in the environment, the test, num, it's numeric data. If you had text, this, for example, is a character data, or datum is character data. So characters, kind of that text, the strings, what we call that in the quotation marks. And I believe you can actually use single quotation marks as well. Doesn't make a difference. Whatever you want. I use double, just looks a bit nicer, but no worries. So there's character types, numeric types, integer types, logical types, and complex types. The only ones that really matter for our course now are the character and numeric types, so words and numbers. If you start doing more in-depth statistical analysis, you'll start to care more about integer, logical, and complex types. There are also different data structures, so vectors, lists, matrices, data frames, and factors. Again, we're only going to focus on 2 of them today. So matrix, the matrix, which is just a table. Matrix is just typical table. And a data frame, which is also a table, but just has more flexibility when it comes to what you can put in that table. So we're just working with tables. But if you are working with R in more depth, you'll see in the slides that I will provide to you that I've listed the data types and structures so that you know what to search for and you know what to expect if you search for these terms. So fabulous. Before we get started, the last thing I want to do is I recognize that this is not the most accessible appearance for a lot of people. I really struggle with the black text on white background. I'm sure quite a few other people do. I'm just going to clear this while I'm at it. So let's say you want to change the way that this looks so that it's more exciting, it's more easy to read. Just head to Tools, Global Options, and then Appearance on the left-hand side. You have this default. You can change the text size. So I'm going to, for the sake of this class, for the rest of it, I'm going to use size 16. I would never use size 16 in my own practice, but because we're recording, I think it is a little bit easier to read. And then you have a number of editor themes. So you can choose which one you feel best suits what you're doing. I tend towards the Tomorrow Nights, just towards the ends. These are the ones I like to use. And I'll probably be using Tomorrow Night Bright for this. Awesome. So apply. Sometimes, depending on the program, you might need to restart R. So, or RStudio. So if you get a message that says, oh, you have to restart the program, no worries, restart the program. It'll look nice, whatever makes you happy. Does it spark joy? Close the program and start it up again. So there we go. So now we have, our Mr. Robot look for R. We have our basic functionality. We kind of know how R works. Let's clean some text. All right. So we're going to spend the next little while just cleaning up, getting our text ready for analysis. We're not going to do the analysis today, but we're going to get ourselves set up so that we can go into our text analysis first thing next week. So first and foremost, you can use whatever corpus you want for this course. We are going to be working with more than one text. So it's important that your corpus consists of more than one text for the purpose of this course. If you only want to do text analysis on a single text, you can do that. I have a slideshow that is public where I teach people how to do that as well. But I'm going to be using multiple texts in this space because I think that's probably what most of you want to be doing. So that's the link. This will take you to a Google Drive with 6 texts in it. The easiest way to do this is to just download them all at once. You should have a separate folder with these texts. They need to be all in a separate folder. Your file should look like this. It doesn't really matter what your folder name is. I've called it N8 texts. And then if you click on it, you'll see my R history because I was playing around with this. There should just be 6 texts in here. So American suffragette, debate, female suffrage, my own story, republic, and unexpurgated. If you click on any of these texts, all it's going to take you to is the text itself. So you'll see that I've cleaned it up a little bit. All I've done is I've gone to Project Gutenberg. These are all public domain texts. Gone to Project Gutenberg. I've removed the beginning and end parts of the Project Gutenberg statements so that they're not part of our analysis. And then you'll see that the entire text is here. But problematically for us, it's full of numbers and punctuation and white space. And what we're going to be doing in this text cleaning is getting rid of all that stuff so we can just get to the text itself. Different languages should be fine. Again, I'll be limited in how I can help you, but it shouldn't be a problem with the text cleaning or the text analysis. So if we're using a corpus in a different language, I'll tell you when that will matter. Done. Awesome. So people are working on it. And these texts, just fair warning, there is no scientific reason for choosing these texts. I just went on Project Gutenberg, saw that there was a bookshelf on women's suffrage and was like, oh, that's interesting. And then picked 6 random texts that I felt represented the debate about women's suffrage. These texts are from 1870 to 1914, and they're all about the women's suffrage movement in the United States and the United Kingdom. I don't know anything about the women's suffrage movement in the United States or United Kingdom around that time. So I thought it'd be interesting to learn. But you can use whatever corpus you feel most interests you. And it might be that you use this test corpus for this session, and then you use a different corpus for next session. So this is when it starts to get a bit difficult, and this is where the learning curve will come in. So if you want to save our progress, you actually don't need to save. If you were to just close this window, it would save for you usually. But if you do want to save our progress, just save or save as. There we go, save, test, save. And you can save it wherever you want to save the code and then press save. But if you close this window, it will usually stay there anyway. So let's start. In order to do this text analysis and in order to clean up our text, we need to first install the package that we're going to use. So this is the package that is specific for text mining. It's called TM. In order to install a package on R, the function you want to use is install.packages, and then in brackets, square bracket, and then in quotations, TM, and run that. You can see that it's running because there is a little stop sign that appears here. If that stop sign appears in your top right corner of the console, it means that a code is running. You can click stop to stop it. I don't know why you would if you're installing a package, but you'll see here the downloaded binary packages. So it's all downloaded. It's downloaded all the tools I need to use the TM package. So we have our package installed. Make sure it's in square brackets. The reason, or not square brackets, sorry, it's in quotation marks. The reason it's in quotation marks is because we don't yet have it in our RStudio. So once you have it in the studio, you don't need to install it. You don't need the quotation marks. So to turn on your package, you have 2 ways of doing this. The function that you want to use is library, and then in brackets, TM. You don't need to put it in the quotation marks because it's already in there, and then run that. So it's loading. If you want to do this the somewhat easier way, just go to the packages tab, click TM. You know that it's on here because it's checked. So it means it's working. So now that we have what we need to do this, we need to set our working directory. We need to tell R where to get its information from, and then where to put the information that we generate. So to do this, click on session in the top bar, set working directory, choose directory. There is a shortcut for this, so Control-Shift-H. There's also a function you can use, but the function is unnecessarily difficult, and I never use it. So I put mine on my desktop. Just click, okay, this is the folder I want, this N8 text folder, and then click open. And there you go. So set working directory, and you can see that where it is, exactly where it is. Now R knows exactly where to get the data from. It's really common to forget to set your working directory. So if you ever get an error and you're like, I don't know what's happening, the best way to figure out where you're working is by using the get work directory, working directory function, which is get WD and then closed brackets. And it tells you where you're working. If you ever want to clear your console, if you find it's just getting a bit messy, by the way, there's always these little sweeping brushes here. So if I were to click here, you can click Control L, it's saying here as well, but just click the little sweeping brush. There's always a little sweeping brush in these. And then this one, you can just, you can close and start again. But if you ever want to clear this console, it's getting a bit messy for you, just click here. And the reason the text is shown in different colors is because the purple means that it's doing something different than the orange, and it's doing something different from the white. Really just focus on the white stuff. The white stuff is the most important thing, but it all does something different. I'm not going to go into detail on that. So great. So now that we have our working directory, we need to import our 6 texts. So let's name a variable. You can call your variable whatever you want. I'm just going to call it texts. All right, there's my variable. And the TM package has a specific function for importing a corpus. And that is corpus with a capital C. This is the main function in the TM. This is what actually gets your text there. The frustrating thing about this, so this is where it starts to get a little bit weird. You have to have an instruction inside of an instruction. So we have our corpus saying we want to pull a corpus. And the way that we want to do it is by using a direct source. So dir source. I know. There we go. Dir source here. Okay. Then, because direct source is another instruction, you have to have another set of brackets. So you're going to have a bracket inside of a bracket. Really annoying. You then need to tell it exactly where to get the information from. So you'll notice that I used my get working directory thing here. That wasn't just to show you where to go to get the working directory. It's also because I need to copy and paste this. So use the get working directory function to figure out where you're working, copy, and then paste this information into the brackets. So this is what this will look like. You have text, the variable name, corpus, which is the function, direct source, which is the kind of function within a function. And then this is the direct source. This is where you want the information to come from. Fair warning that texts need to be a text file. So if you're working with Word files, don't, it's because the text files are in Unicode. It's okay if the outputs in the console don't look like mine, as long as they look sort of, as long as there's no error, yours might look different, no worries. But you have to be using text files for this. So let's run this. So you'll notice here, great, we have something in the environment. We have our little variable here. We have 6 elements. Let's click for more details. That's not very helpful, is it? But it gives you a little bit of a feel for what's underneath the variable. So you can scroll through here. There are easier ways of getting this information, but we have a large, simple corpus. So that's imported. Fantastic. So if we want to see what this text looks like, I'm getting this error, unexpected / in text corpus direct source. So it usually means that there, oh, here we go. So you put there's a quotation mark after C plus C:/. Put the quotation mark so it includes the C:/. So make sure that everything is in the quotation. Everything in your R should be a different color. And that's a way of saying, okay, this is a string. This is everything that's being included. So based on what you've just put, Claire, it looks like your quotation mark's just in the wrong place. So great thing about coding, one thing goes wrong and then, you know, everything screws up. It's great. It's great fun, problem solving. Okay, one more question, then we'll move forward. Error in corpus direct. Oh, make sure that direct source is, so corpus has to be a capital C. Direct source has to have a capital D and a capital S. Remember that R is case sensitive. So if I put something in capitals, make sure you're putting it in capitals as well. So super easy fix. So let's move on. So say we just want to see, okay, what do our texts look like, right? We have 6 texts. What's going on here? You can use a function called writeLines. This is a base R function. We want to see the characters that are in this text. So we're actually, it's telling us what to do here, but the way to do this is as character, and then texts, because we named text. So as write lines is a function. Again, this is a function within a function. It's telling us to get this from texts. And then we use the square brackets. Oddly, this one requires double square brackets. I'm not going to go into detail about why single versus double square brackets, because this is just to give you a feel. This is not necessary. But if you wanted to see what this looked like, I think I am forgetting a bracket. I'm forgetting a bracket. I am not forgetting a bracket. I'm forgetting a bracket here. That's where I'm forgetting a bracket. There you go. So you'll see that we have the text here. It's all imported. If you're not seeing something under environment, it's because you haven't named a variable. So make sure that you're naming a variable. Sorry, I'm just answering questions as we go. So there you go. That's our text. We know it imported. This is the 4th text in the series. It's all fine. But remember, as I said, part of the problem is it has all this punctuation in it. There's a lot of white space here. No, there are things that like capitals, lower cases, it's a mess. It looks as it should as a text, but it's a bit of a mess. So let's clean it. This is where the proper cleaning comes. We have about 10 minutes, so I'm gonna close the chat for now. If for some reason this isn't working for you, I will send you the slides at the end of this, and I encourage you to go through the slides where I've put this code and try running it yourself. But just for the sake of time, I'm closing the chat for now. Also, if you're struggling, just look at what I've written and see if you can try to make your code look like mine. So the function that we use to clean up text is called TM mapping, or TM map. What is TM map? Now is a good time to use the help button. There's an internal server error, because of course there is. This means that it's just having trouble getting to the connecting. This is probably have to do with my connection. So let's ignore that then. So if you want to know more about the TM map function, I was just going to show you what it looked like, but it's no problem. Just give it one more try. No, internal server error. Just means the connection's a little off. This happens super rarely, so I'm not concerned, and you shouldn't be either. But yeah, have a look at the TM map. The thing that I wanted to show you with that was that in order to do TM mapping, so you're mapping your text, you're changing the cartography of your text, you use something called get transformations. I don't know why my R is, I know, oh goodness. Okay, so it's getting mad at me for trying to request help. So get transformations. Oh, good God. I clicked help so many times. So get transformations. This will tell you all of the transformations that you can do to your text. So we can remove numbers, remove punctuation. We can remove certain words. So if there's certain words you don't want to look at, we will do a little bit of that. We can stem the document, which we're not going to be doing because stemming in this case doesn't make sense. But anyone who works with lemmas or lemmatization, so just the root parts of words, this will appeal to you. So the linguists in the room might benefit from stem document, and then strip white space. So let's have a go. Every time you change your text, you want it to give it a new variable name. And the reason for that is if you make a mistake, if you mess up, you can always go back to a previous version. So for sake of clarity, not so much clarity, but sake of ease, I'm just going to use texts 1, texts 2, text 3. If something else is clearer for you, use that. So for the first thing, we're going to remove punctuation. So I'm going to call this texts 1. You can call it like texts no P, texts punctuation, or whatever you want to call it. But texts 1. And the function that we're using is TM map. I know it's still trying to get help. So great. You then need to say, so if you see this little yellow button at the top, it says X and then function. That X usually refers to what variable are you trying to work with here. So we're trying to work with texts, the variable texts. That's this what we named up here. So we put texts in, And then we put remove. This is the function we want to do, punctuation. And remember that punctuation is capitalized because it says it's capitalized here. If you don't do capitalize, it's not going to work. So let's run that. Remove. Oh, I spelled punctuation wrong. Punctuation. Oh, good God. Punctuation. It has been too long of a day. There we go. And now we have a new folder or a new variable with no punctuation. So all of our commas, our colons have been removed. Next step. Okay, we're going to keep cleaning. Texts 2, new variable because we're doing a new version of the text. TM map, same thing. Good God. I should really close this and turn it up. Well, whatever. Now this time, the file that we're altering is not text, right? Remember that we altered texts. So we need to refer back to this one, text 1. Text 1. We're going to remove all the numbers this time. We don't want any kinds of tables of contents or any of that nonsense. So remove numbers. There you go. Now we have texts 2 with no numbers. Let's do this again. You're getting the hang of this. So text 3, TM map. Text 2 this time because we're altering our last version. This one's a little bit different. So the function that we're using isn't listed in this one. We want to make everything lowercase. In order to do that, we have texts 2, content underscore. If I can get stop. It's still trying to call for help. Transformer. That's another function to lower. So this one's a little bit difficult. So TM map, we want to alter texts to content transformer with the underscore to lower. If you want to make it uppercase, I'm sure you could by doing to upper, but there you go. There you go. Now we have an entirely lower case. So now we're moving on to text 4. Okay. We have 2 more things we need to do. So text 4. Okay. TM underscore map. My goodness, driving me nuts. Map. We're working with texts 3. And we want to remove words. We want to remove all the stop words. So stop words are also called function words. They're things like the, the words that don't really add tons of meaning to the text. Depending on what you're doing, you might not want to do this. So if you're doing stylometric analysis, for example, you never want to remove the stop words. But for most content analysis, you won't want the words like and the, because they're going to be your top used words. And that's not actually that helpful for a lot of content analysis. So remove words, comma, stop words. We're telling it exactly what we want to remove. This would be different if we wanted different words removed. And then in brackets, tell it what language you want to remove. So English for me, remember this is always lowercase in this one. So if you're working with a French corpus, for example, put French. Make sure that French is lowercase. If you're working in, I think they have like Bulgarian or various languages, you can do that. The list of languages is available in the documentation. So TM map, text 3, remove words, then tell it what words you want to remove, the stop words, and then flag it. Oh, we're working in English here, so it's not looking for stop words that are in Italian, for example. And then run it. This will take a while. For me, this always takes a few minutes. And you can see, this is a great time for me to check out the chat. You can see this little stop button in the console, which means if you can click that button, it means something's running. So I'm just going to leave it and we'll wait for the environment to come up, and then I'll look at the chat to see if there's any things here. So Beatrice has gotten help from Amy. Fantastic. Oh, love to see y'all helping each other. Would you explain why you want the text to be in all lower? Yeah, Helen, the reason we want the text to be all lower is because remember that R is case sensitive. So if the word the is capitalized with the T, it means it will be treated differently as the all lowercase version. And we want all these words to just be treated the same no matter where they are in the sentence. So that's why we want to have everything in lowercase. You could do it in all uppercase too if you really wanted to, but that might be a bit weird. Lowercase is just easier to read. My texts for has come up. So there we go. So we have our text. And the final thing we want to do, right? We have a text that we've removed the punctuation from. We've removed the numbers. We've lowercased everything. We've removed all the stop words. The final thing we need to do, you don't really need to do this, but it's kind of nice, makes analysis a little bit quicker when it comes to actually computing time. Text final, just to signify we're at the end of this cleaning process. TM map, text for, it's driving me nuts. TM map texts for strip white space. If I can spell white space. So strip white space. So we're getting rid of all of those paragraph bits, you know, the bits between paragraphs. We're not getting rid of the spaces. We're just getting rid of all of the unnecessary white space, unnecessary for text analysis, not for the text itself. So there you go, text final. So what does this look like, right? Remember at the beginning, we use this write lines function. Not necessary. You don't have to look at your work at all. You don't want to, but I'd encourage you to have a look. So let's have a look at what we've done. So write lines as character, telling it we're working with text here. Text final, and then in double square brackets, 4. So that's the 4th text in our corpus, in the final version of our corpus. And you'll see here that the entire text has now come up in the console. So you'll see that there's no punctuation. There's no unnecessary white space between paragraphs. Numbers have been removed. There might still be a little bit of weirdness here. So for example, if your book uses, if your text uses Roman numerals or something, that will show up. I'm not particularly concerned at this point. If you were doing some really scientific study, it might be nice to clean that up yourself and just get rid of it. But study after study on R and computational text analysis has shown that there is room, there's quite a lot of room actually for noise. And this counts as noise, the stuff that isn't really that important. I'm not sure what's going on here, not super concerned. But if I were doing some sort of more in-depth study, I would look at the different characters that are showing up and see if there's anything in the original file that I could then just make sure I got rid of all the kind of noisy bits. But you're seeing here, okay, no problem. All good. And then the final thing, the very final thing that I'll end with, so we're going to make a document term matrix. Remember, a matrix is just a table, and a document term matrix just means that the document name is on the left-hand side, the y-axis, and the term is on the x-axis. So we can use the function document term matrix. I'm going to call it DTM. That's my variable name. Text final. There we go. So now we have a table with all of the words in our text, right? So if we wanted to look at that, inspect DTM. There you go. So we're already starting to count words and put them into categories. So you'll see that the term government, for example, appears 16 times in the first text, 139 in the next text. Will, woman, women, suffrage, said, all these words and the number of times they appear in each text. So we've cleaned our text. We've started to analyze a little bit. We've started putting things in tables, so that will set us up really nicely for next week. We've scheduled this with a week in between sessions so that you have time to practice getting to grips with this new language. Remember, as I said at the beginning, you are literally learning a new language. And just because you kind of turned Duolingo on, for example, doesn't mean you're automatically fluent in French. Just make sure that you give yourself the time and the practice to actually learn that language, get familiar with it. You don't need to master it in a week. You absolutely do not need to master it in an hour and a half. If it's helpful for you, use the notes. So say, okay, I just want to remind myself, Octothorpe here, this is make table with terms and numbers, or however you want to describe it to yourself, and then save your code that way. I also have the code that I've used today, so I will make my slides available to you after the fact, after today's lesson, so that you can review this on your own time. Do not worry about remembering this, but remember that in coding, you have to be exactly right. There's no gray area. You have to capitalize things that need to be capitalized. You need to lowercase things that need to be lowercased, and all that fun stuff. It gets really kind of nitpicky, but usually RStudio will tell you what's wrong. So for example, in the kinds of error messages that you were getting in the chat, you will tell you what's wrong. You may not be able to interpret what it's telling you, but it is telling you. And as you become more familiar with R, you'll start to be like, oh, I get it, right? Just to wrap up, let's go back to our little PowerPoint where I will then, that's my code. All right, so current slide, just very quickly, as we go through the week, as you're practicing your code, you're like, I have no idea what she's on about. I don't know what to do. Please help. SOS. Here are some places that you can go. So there are tons of R communities online. Here are some of my favorites. R Ladies is a great one for women in code. There's a real sense of community in there. They do a lot more than just workshops, although their workshops are great. They also do local meetups if this is something that you'd be interested in. R Forwards is also for marginalized groups in code. So really great opportunity. Stack Overflow is also the one, if you have a specific problem, someone has already asked it in Stack Overflow. So there are some online communities there. You have some R resources. So if you're like, I want to learn a bit more, or I need to review something, here are some of my favorite R resources. Those of you, I think there was some in health sciences, you might benefit from Emma Rand's Reproducible Analyses in R, which was a previous N8 training session. It's available, the recording of it's available over here. The LinkedIn Learning portal as well. Most of our universities, if not all, should have access to LinkedIn Learning, and they have some fantastic stuff, especially about social media analysis and company reports. So there are two of you who are doing stuff like that. Really encourage you to look at the courses that are on the LinkedIn Learning portal. For those of you who are doing individual text analysis, the work that I always base my teaching off of, so if you're working with just one text, go to Matthew Jocker's Text Analysis with R. It's the kind of gold standard of what to do. Really good explanations as well. You will know exactly what you're doing by the end of that book. And then finally, if there are some other packages you want to try out, I've used the text mining package here, but I've given you a selection of other text analysis tools that you can check out on your own time. Stylometry, the Stylo package, is the one that I would consider myself pretty expert in. So if you ever want to have a chat about stylometry, I'm here for you. But the other ones I haven't used as in depth. I just know that they work.